Hello and good evening, everyone. Thank you for joining us. We are Group J3, and our team consists of Abdul Rahman, Basu Bosnet, Milan Khadka, and Muhammad Fazil. Today, we are presenting about analysis of high-speed rotor, modes of failure, and damage detection. In this presentation, we will dive into the design and structural components of high-speed rotors, explore their potential mode of failure, and discuss advanced methods for damage detection. The rotor system shown here is a key component of modern engineering systems, and our analysis highlights its critical role in ensuring operational reliability and safety. Can you go to the other slide? First, I am introducing about high-speed rotor. It is a crucial component in a mechanical and electrical system. They serve as a central part of a machine that require rapid rotational movement to perform their function. High-speed rotors are commonly used in various industrial and commercial equipment. For example, in systems like gas turbines and steam turbines, rotor plays a vital role in energy generation by converting fluids into mechanical energy. And also, for example, in air compression systems, rotors rapidly spin to compress gases for industrial process, and high-speed rotors are key to generating mechanical motion from electrical energy in electric motors. Can you go to another slide, please? In this slide, I am explaining why to prevent rotor failure. Preventing rotor failure is important to keep industrial operations running smoothly. When a rotor fails, it can cause serious damage to machinery, leading to expensive repairs that may cost millions. It also results in unplanned downtime, which disrupts work and reduces income. Taking steps to prevent failure help save money, avoid delays, and keep everything working efficiently. Can you go to another slide, please? This slide consists of objective of the study. First is to investigate the failure mechanism of high-speed rotors using finite element method, and then to improve rotor design and develop better maintenance strategies to enhance their reliability and performance. Can you go to the another slide, please? And finally, I'm discussing about the state of art review. It analyzes high-speed rotors. It emphasizes advancement in finite element method FEM simulation to identify key factors like stress concentration, thermal stress, modal analysis, and vibration patterns. Additionally, it explores techniques for early damage detections such as vibration analysis, non-destructive testing entity, and acoustic emission monitoring. Emerging technology like machine learning are also identified as a promising tools for enhancing rotor analysis and maintenance. And now Milan will explain his part.
Okay, now here comes the methodology part, and on this slide we will be discussing what are the key techniques for the failure analysis. Uh, the one of the major approaches for the failure analysis is the finite element method. In short, we can say it FEM. Is basically a numerical method uh, that solves the complex engineering problems, and it helps to break down the larger system into the smaller system, into more manageable parts, and also help to simulate and analyze the behaviors of the different components under the various conditions. It basically comprises the three main categories. The first one is stress analysis. The stress analysis basically analyze the centrifugal and thermal stresses, and the another is the modal analysis. It identifies the vibration modes and the natural frequencies, and another one is the fatigue life estimation. It predicts the crack propagation over the time. By simulating all these conditions, we can identify which part or which component are more susceptible to the failure, and also we can prevent the unexpected breakdowns and also optimize the design for durability. So the another approach is the technique for early damage detection, and it also comprises the three main parts. The first one is the vibration analysis. It basically detects the imbalances and misalignments and the cracks. And the another one is the thermal monitoring. It identifies the hotspot due to the wear. And the another one is the mm, acoustic erosion monitoring, which basically compares or computes the signal from the crack propagation. Can you please go to the another slide? So for the implementation of all these techniques and methods, we need some advanced softwares and the tools. So basically, for the analysis of failure analysis of the rotors, we can use softwares like the ANSYS or Abacus or COMSOL. And beside this one, there are a few sensors that are also used for the real-time data collection. For instance, uh, accelerometers or thermocouples or strain gauges. These are the type of sensors that are used for the collection of the data. And beside this one, there are some standards that must be considered. So the standards are basically the ISO 91406 or ISO 10816 and the ASME standards. And basically all these tools, softwares, and these standards provide a framework for analyzing and monitoring the high-speed rotors. And here on this figure, we can see that the analysis of high-speed rotors by using the ANSYS software. So we can use the software like this. And can you please go to the next slide? So while talking about these finite element method, there always comes the comparative analysis of this method with the traditional method. Uh, and When comparing the FEM with the traditional method, FEM basically offers the simply significant advantages. For example, it is easier, faster, more cost effective, and particularly doesn't rely on the prototypes, whereas the traditional method can be more slow or more expensive. And while discussing all these, there always arise one question, which is why FEM? Because FEM provides the more predictive, more precise predictions and about the failure mechanism, and it also allows to optimize the design without repeated testing. So basically, it is preferred or it is chosen over the analysis of the high speed rotors over other methods. So from here, my friend Fazil will take over.
Uh, Hi, I'll talk about the results of FEM and its impacts. I will talk about the technical impact. Finite element method analysis has significantly improved the technical reliability of high-speed rotors. By utilizing predictive failure analysis, engineer can identify critical stresses points and address them during the design phase, thereby enhancing the system overall reliability. Another key benefit of FEM is its ability to detect and mitigate the risk associated with the resonance. Model analysis through FEM identifies natural frequencies and critical speeds along operational adjustment that prevents catastrophic vibrations. Furthermore, FEM simulations offer detailed insight into stress distributions and thermal behaviors, in enabling engineers to refine rotor designs for greater durability and performance under extreme conditions. Financial impact. The financial benefits of FEM-based analysis are equal noteworthy. Predictive maintenance facilitated by FEM reduces the cost and frequency of unplanned repairs by addressing issues before they escalate. Additionally, FEM simulation estimate the need for extensive physical prototyping, saving both time and development cost. These savings are particularly significant for industries where prototype and maintenance are resource intensive. Finally, the ability to prevent catastrophic failures, often expensive to repair, makes FEM an indispensable tool for cost-efficient rotors failure prevention. Next slide. Now I'll talk about the discussion, what benefits it has in the business sector as well as organization considerations. In the business benefits, adopting FEM-based analysis provides several business advantages. First, it boosts customers' confidence by ensuring reliable and safe rotors performance, which is critical in sectors like aerospace, energy, and manufacturing. Customer value products that are less prone to failure, and FEM ensures that companies can deliver such products consistently. Secondly, FEM fosters innovations by allowing engineers to experiment with additive designs such as lightweight composite rotors. These designs not only improve efficiency but also position the company as a market leader in adopting cutting edge techniques. Organizational consideration, while the benefits of FEM are substantial, its implementation does pose organizational challenges. Engineers must be trained to operate advanced FEM tools and interpret results accuracy, which may require dedicated upskill programming. Additionally, adopting FEM may necessitate new softwares or sensor systems such as accelerometer or strain gauge to collect precise data for simulation. Integration with existing diagnosis workflow can also be a challenge, uh, as it often require upgrades to existing systems or the adoption entirely new platforms. However, once implemented, FEM tools can automate routine diagnosis tasks, freeing engineers to focus on innovation and strategic problem solving. Now, my friend Abdurrahman will come and explain the conclusion part.
Well, the conclusion to this study highlights the comprehensive approach taken to analyze high-speed router failures using advanced methods like finite element methods and diagnostic tools. We focused on evaluating stress concentration, thermal effects, mode analysis to gain a deeper understanding of underlying failure mechanisms. Then it comes to the benefits we got from this study. First one is by early detection of faults. By leveraging techniques such as vibration analysis and acoustic emission, monitoring faults can be detected at an early stage, minimizing downtime and catastrophic failures. Then comes to the enhanced router design. The insights obtained have directly contributed to design safer and more efficient routers, significantly boosting operational reliability. And the cost effectiveness, which incorporating FEM reduced the dependency on expensive physical prototype, thereby cutting down development and maintenance costs. Then it comes to the challenges we faced during the study of the routers, and that, however, implement such advanced technologies like the high initial investment in acquiring tools and training personnel possess a barrier for organization. And integration with existing legacy systems often demands additional efforts, making it essential to plan for seamless transition. While overall, I can summarize this into like the study not only advances our understanding of router failure mechanism, but also establishes a framework for predictive maintenance and enhanced router performance. By balancing the challenges and benefits, the proposed methodologies promises a transformative impact on industrial applications. Thank you.